batch size optimization or lot size optimization. So batch size is a terminology typically for the process industry, lot size for discrete manufacturing industry. Both comes with a similar challenges to optimize. So let's have a look where is it located and what are the challenges itself. If we think again on the planning metrics which we had there, we have to specify the lot size that we can really do the scheduling itself. And this lot size or batch size, they have impacts on two dimensions. From a planning perspective, you can imagine that we can order only on lot sizes or on batch sizes towards our production facilities. In theory, we would like to have lot size 1. That means you can really order any kind of quantities and then you're really fine in a sense that from a stocking behavior and a demand behavior towards your customer, this would be the optimum thing. The reality for many industries is that you can order only batches or a tough amount of lots overall, maybe thousands or even 10,000s of pieces of a certain product, or maybe even a ton of a certain ingredients in process industries. And this lot size itself, it has, of course, for the scheduling, huge impact how we schedule our products. If the lot size itself is getting too big, then you're producing for a long time only this article. If the lot size is getting maybe too small, you end up always with set up times between different products. So you squeeze a little bit from the optimal ordering behavior from the inventories, and this is then later also related to the lead time itself. So how long does it really take to do the production cycle overall? And from the optimization possibility, you could say from a shop floor perspective, always big lot sizes is better than small lot sizes because you don't have any kind of overhead of change over time, and maybe you have even a production facility which is continuously producing only one product. That would be the max case on production side. Let's have a look on the classical mathematical solution of this, and this is a very well-known formula, the so-called economic batch quantity. I think as well developed already in the early 20th century. On the left side, we see a little bit the cost behavior. We have one cost part which increases linearly, So that's associated to the materials, labor cost, handling cost, and storage cost. The more you produce, or so the bigger the batch itself, so the higher the cost itself, linear increase. And then we have the part which is on a convex curve. So that's really something with, as I say, to your machines, the setup times and the paperwork, pre-processing work in itself. If you add both cost parts, you have this total cost, and then you're searching for the minima, and you're all fine. And the input variables of this classical formula is the demand of the entire year, the cost of setup, the inventory holding costs. Then you have how often the inventory is really demand, so the cycle or how often it is ordered, that's coming from the order part, and the rate of production per annum, per year. And this really gives you the formula. I think when you set up a production facility, this is the standard way how you really try to define your batch size, fair enough, but the reality is way more complex. The cost part normally as well for the handling is not really linear. Think about a very simplistic thing that you have storage problems. Yeah, you cannot just produce, and suddenly you have maybe a problem on size, or you have shelf life problems. You cannot produce something just in huge batches, and then you have maybe the shelf life of the product. You have other constraints suddenly there and write-offs. And this is a problem for both cost parts. These optimal curves here are really only the starting point. The reality in the background is way more complex, and it really depends on the situation. As a starting point, good, but for really looking on the full chain itself is only one part of the overall optimization problems, the economic batch quantity. I think this concludes this part. It only addresses or scratches the surface, but we have seen the economic order quantity, we have the economic batch quantity, and there's as well economic delivery quantity. So you see there already, if you look on the full supply chain, you get problems. Optimal order, optimal production, optimal transport. All of them are a little bit contradicting. You can really isolate them and really optimize them separately, but still you are affecting always another piece. And this is often the biggest challenge of this batch quantity as well. Good for the shop floor, bad for the warehousing. That's normally the thing in the batch quantity dimension. Enough for now. We are now entering into the overall equipment efficiency.